So today we are going to see the combination of resistors. Combination. Okay. Like we have series combination. Series combination. Suppose there is one resistor like this. There is another resistor like this. This is R1. This is R2. Here potential is suppose V. Here potential is.
And in which direction?
Means suppose we connect like this.
In which direction?
We are connecting these resistors by a battery. Right? Battery of voltage V. So what will happen? Current will like this. Suppose I current is flowing through this battery. So in series, what we say that current remains the same. Means if 2 ampere is flowing from R1, 2 ampere will flow through R2 also. So what is the definition of series? That current in series, current is same. Current same. Means if 2 ampere is flowing through this resistor, 2 ampere will flow through R2 resistor. If someone asks what is the voltage across this resistor, voltage across resistor 1. So can you write V1 equals to I R1? So current is I, resistance is R1. If someone asks what is the voltage across this V2, so current is I, resistance is R2. Correct? So series current is same, but voltage is different. In some case it might be same if we have the same resistor. So here also IR, here also IR. That is special case. Else voltage will be different. Now always remember this V1 plus V2 should be equals to V. This voltage drop V1 plus voltage drop V2 should be equals to V. Correct. Very important. This voltage drop plus this voltage drop should be equals to V. If I replace this arrangement by a single resistor, everything same. Voltage V, this point is same, this point is same. So what is the potential of this point? V, V, V. What is the potential of this point? 0, 0, 0. Similarly here, what is the potential of this point? V, V, V. 0, 0, 0. Just we are replacing these two resistors by a single equivalent resistor. So they asked what will be the R equivalent. Okay. So R equivalent, always remember in series is what? R1 plus R2. Just we add R1 plus R2. Correct. So R equivalent will be R1 plus R2. It is like suppose there are two bouncers in your house to protect your house. One bouncer is having power 20 and another bouncer is having power 30. Now one day you think that I will not keep two bouncers. I will keep only one bouncer in my house. So that bouncer should have how much power? 20 plus 30, 50. Understood? Like this. Okay. He must be that powerful, so that to substitute them. Similarly here, the equivalent resistance, if we place one resistor, what should be the equivalent value? R1 plus R2. Okay. Next is parallel combination. Here, voltage is same across the resistors. Current may or may be different, but voltage is always same. Current will be different. In special case, current might be same, but normally current is different. For example, this is R1, this is R2. And there is a battery like this, V volt. Correct? What we can see? If this V is voltage, this is also V, this is also V, this is also V, this is also V, and this is also V. If this is 0, this is 0, this is 0, this is 0, this is 0. I told you yesterday, across the wire there is no potential drop. So what is the potential difference first across first resistor? V minus 0, V. What is the potential difference across second resistor? V minus 0, V. Same potential difference. See, voltage is same. But current may be different. Suppose I current is flowing through the battery. I current is flowing through the battery. I current is flowing through the battery. What will happen? Some current will go there, suppose I1, and some current will go there, I2. So what we can write? This I should be equals to I1 plus I2. Correct? Some is like out of 5 ampere, 2 ampere is going this side. So how much it will go this side? 3 ampere. 2 plus 3, 5. Acha, since this resistor, what is the voltage of this resistor? What we can write? V equals to IR1. So I1 R1. What is the voltage across this? I2 R2. I2 R2. And we know that the voltage is same. Voltage across this and voltage across this is same. So we can write this equation also. Okay. So this is parallel combination. If we replace by a single resistor in this situation, if we replace by a single resistor, then what will be R equivalent? Always remember, if two resistors are parallel, because most commonly two resistors are in parallel. Most commonly they will give like that, two resistors are in parallel. So R equivalent equals to, you multiply these two, R1, R2, divided by, you add these two, R1 plus R2. First you multiply, divided by, then you add. But what is the general formula? General formula means, if we have more than two, like if we have one resistor like this, one resistor like this, and one resistor like this. This is R1, this is R2, this is R3. Then if we want to replace by a single, what will be R equivalent? So always remember, the formula is 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. Now what people do mistakes, now they solve this and suppose answer is coming 2. So they will write 2. No, 1 by R equivalent will be 2. So R equivalent will be 1 by 2. These small things little bit you have to take care. Correct. Suppose First question, what is the voltage across 3 ohm resistor? Second question, what is the current across 2 ohm resistor? Can you solve? Try to solve. Ah, current? No, no. What is the answer? Voltage. What is the answer? 12. Okay. Correct. 4. This is the first what you do, you have to find the current. So this is in the series, so current will be same. So what will the current? Current we can write voltage divided by R equivalent. Net resistance. Voltage is 20. R equivalent is 3 plus 2, 5. So 4 ampere. So 4 ampere will come out to the battery. Since it is in series, here also 4 ampere, here also 4 ampere. Now they ask what is the voltage across 3 ohm. So V equals to IR. I is 4, R is 3. So 4 into 3, 12 volt. Correct? Next. Suppose we have like this. $20. This is 10 ohm. This is also 10 ohm, suppose. You have to find what is the current, or you write now this 20 ohm. What is the current flowing through 10 ohm resistor? How much current is flowing through 10 ohm resistor? You have to find this. Huh? What is the current through 10 ohm resistor? See, we can make a equivalent resistor like this. This is R equivalent. We can replace these two by R equivalent. This is 20. What will be R equivalent? What I told, multiply these two, 20 10 ja 200 divided by, add these two, 20 plus 10, 30. So 20 by 3. This is R equivalent. What is the current from the battery? This current I am asking. So current will be, see, V equals to IR, I equals to voltage divided by resistance. Voltage is 20 divided by net resistance 20 by 3. 20 by, so how much? 3 ampere. So 3 ampere current will flow from the battery. 3 ampere. Means here it will reach 3 ampere. Out of 3 ampere, some current I1 will go here and some current I2 will go there. Means what we can write, I1 plus I2 equals to 3 ampere first of all. Second, whatever voltage across this, same voltage across this, they are in parallel. So voltage equals to IR1. So I1 resistance is 10 equals to voltage across this I2 resistance is 20. So what we are getting? 10 1 ja 10, 10 2 ja I1 equals to 2 I2. You replace here I1 equals to 2 I2, 2 I2 plus I2, that is 3 I2. 3 I2 equals to 3. This implies I2 equals to 1. Means current here will be 1. And if current here is 1, how much current will be there? 2. So current through 10 ohm will be 2 ampere. Simple. Right. One more thing, this will help to save your time. Suppose in parallel, we have lot of resistors. Like suppose this is R, this is R, this is R. They are in parallel. So R equivalent will be R by 3. 1, 2, 3. If all are R by 3. Similarly, if we have like this R, 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 and this is n times, 4 times, 5 times, 6 times. If it is 3 times R by 3, 4 times R by 4, 5 times R by 5, n times R by n. Equivalent resistance. Correct? So these things are going to save your time. Now see, two things. First of all, suppose current is flowing like this. It has two paths, one here, one here. Here there is a resistance, suppose 2 ohm, whatever. And here there is just connecting wire. This is just connecting wire. Acha, connecting wire resistance, what we take? 0. Now you think like, suppose you are running. Now you got two paths. One path this side, one path this side. This side has some resistance, means something opposing you. Resistance means something opposing you. But and this side there is no resistance. No one is opposing you. Which path you prefer to run? This path only, because there is no one ready to oppose you. So what will happen? This all 2 ampere will flow from here. No current will go through this. No current will go, so you can remove the circuit. Means what you can do, all the current will go, you can remove it, no need to draw. So 2 ampere current, suppose 2 ampere is going there. I will take one example so that you understand better. Okay. For example, see. This is A, this is B. They are asking what is the R equivalent between AB. R equivalent between AB. See what will happen. You start from A. Acha, you start from A like this. Go like this. Like suppose current is flowing from here. It is going like this. Here it reached. It will see two paths. One path there, one path there. In this path, there is no resistance. So current will flow, all the current will flow in this path. No current will go that path. So all the current will go flow through this path. Okay. Now again, when it will reach there, it will come to, from A to B they are asking, no? So you have to come back to B. So this you can disconnect. This you can disconnect. What I am saying, you can disconnect from the circuit. No use to, you can leave it. So see, only this R and this R in series. So R equivalent will be 2R. Correct? One more question. A, B. They are asking again same question. What is the R equivalent between AB? See what will happen. You start from A. Some current will go here. Some current will go there. All right, now you don't draw like this. Suppose current is going like this. When it will reach here, see here, when it will reach here, it has two paths, one this path and one this path. This path has resistance, but this path don't have resistance. So it will travel in the path which has no resistance. So it will not go in this resistor, it will go like this. So no current will go through this resistor. If no current is going through this resistor, you can delete this resistor. You can delete, perfectly delete like this. Now our figure, see, this is R and this is R. It is like this now. See, this R and this R in parallel. Achha, if you are having confusion na, whether they are in parallel or not, you name any point. Suppose this is C. This point potential is C. This point potential is D. So if it is D, this is also D. If it is D, this is also D. So this resistor is between C and D, potential difference C and D. This resistor also potential difference C and D. So they are in parallel. So R and R parallel. R equivalent will be R by 2. So what you do? You remove this. They are in parallel. You remove this and write R by 2. R by 2. Now all three are in parallel. No, here we have R also, na? Here we have R also. This R and this R by 2 in series. This R and this R by 2 in series, back to back, see? Series. So R plus R by 2, 3R by 2. R plus R by 2, 3R by 2. So remove this and the equivalent will be 3R by 2. Now all are in parallel. So 1 by R equivalent equals to 1 by 3R by 2 plus 1 by R plus 1 by R. You can solve this and get the answer. Okay. Now whatever be the answer. Whatever. Correct. Next we have ladder circuit. Sometimes they ask ladder circuit. So there will be an infinite ladder like this. This is A, this is B. Okay. Like 1 ohm, this is 1 ohm, this is 2 ohm. Again 1 ohm, 2 ohm. 1 ohm, 2, like this. This is infinite ladder. See now, it is extended till infinite. They will be asking what is the R equivalent between AB. How to solve this kind of questions? See. So infinite ladder, what we do now? Suppose the R equivalent is X. We don't know what we will write. The R equivalent is X. Of this entire circuit, R equivalent is suppose X. Our answer will be X basically. Now always remember, if there is, suppose you have infinite balls. If I take one of the ball, still you will be having infinite. There will be no changing in answer. Means if you have infinite items, if I take one item out, still your answer will be infinite. In ladder circuit, what we do now? First we see the pattern. What is the pattern? Like see, this is 1, this is 2. Correct. And this is being repeated. So first you take out the pattern. This is 1, this is 2. And this pattern is only repeated. So this is the repeating pattern. This pattern will repeat. Now what you do? One pattern you have taken out, break it like this. Okay. Like this or like whatever. Just I am saying you can separate. What I am saying, if I remove this, suppose then there will be no change. Same thing, na? 1, 2, 1, 2, 1, 2. You have removed only one thing. So same thing. So this answer will be also be what? X. Means whatever was behind this, its answer will also be X. Correct? Now you solve this 2 and X in parallel. So what will the answer? 2X divided by 2 plus X. You will get one R equivalent here. This, and this is in series with 1. So net R equivalent will be this plus. Correct? This will be the answer. 2 and X will be 2X divided by 2 plus X. You will get one resistor. This resistor and this resistor in series. So series we will add. So this will be our answer. So what we assume our answer? X. So this will be equals to X. You will get one quadratic equation. See here, like 2 plus X. This is 2X plus 2 plus X equals to X. So from here cross multiply. So X square plus 2X is equals to 3X plus 2. 3X plus 2. So finally X square plus 2X minus 3X means minus X minus 2 equals to 0. This is a quadratic equation. You will get the answer. You know how to solve quadratic. Minus B plus minus root D, B square minus 4AC by 2A. Or you can do the factorization also. Whatever. So ladder circuit we solve like this. They sometimes ask in the exam. Important. Okay. Now next, Kirchhoff's junction law or current law. Kirchhoff's current law or Kirchhoff's junction law. Normal thing, you have studied only. Suppose like 2 ampere is flowing in the circuit. Here is one resistor and here is one resistor. This is 4 ohm resistor. This is 6 ohm resistor. Suppose, just example I am taking. When this current will reach at the junction, it will not get stored. It will flow only. Some will flow here, some will flow there. So out of 2 ampere, suppose 0.5 ampere flows there or 1.5 ampere flows there. So how much it will flow here? 0.5. This is only Kirchhoff's current law. 0.5. Means there will be no net current in the junction. Net current in the junction will be 0. That's why it is also called junction law. So sometimes they give little bit different kind of question like this. They will give, this is 0 volt, this is 4 volt, this is 6 volt, this is 1 ohm, this is 2 ohm, this is 3 ohm. They will ask what is the current flowing here, this current. Like this they will ask. How to solve? Always remember, see, whenever this kind of question comes, what we have to do, see the process, very easy process. Suppose there is any junction like this. Some voltage will be given here, some voltage will be given here. Suppose this is V1, this is V2 and some voltage here V3. This voltage we don't know, so we will write X. Suppose the voltage is X. Now we have to calculate X. Suppose here there is one resistor R1, here there is one resistor R2, here there is one resistor R3. We have to calculate X. How to do? We will apply current, Kirchhoff's current law. What it says that at any particular junction there is no current. No current means that, see, suppose what we assume, how we solve this kind of questions, we assume that this voltage, just we assume, you assume that this voltage is higher than the neighbor voltage. Neighbor voltage means this voltage, this voltage, this voltage. You assume it is higher. So this is high, this is low. So current will flow from here high to low. Similarly, current will flow from high to low like this. Similarly, current will flow from high to low like this. The sum of all the currents, suppose this is I1, this is I2, this is I3. The sum of all the currents I1 plus I2 plus I3 has to be 0. Understood? I1 plus I2 plus I3 has to be 0. Can you solve this question? See, this was the question. What you do, I will mark this voltage X and I will assume that this voltage is more than the nearing voltage. This is just my assumption. So if this voltage is high, so current will flow like this, current will flow like this, current will flow like this. And I will say this current, suppose I1, this current is I2 and this current is I3. Sum of all the currents, that is I1 plus I2 plus I3, will be what? 0. Now I1, how we can calculate I1? Voltage divided by resistance. Voltage is what? X minus 4. X minus 4 divided by resistance 1 plus what is I2? Voltage divided by resistance X minus 6. Voltage divided by resistance 3 plus I3, voltage X minus 0 divided by resistance 2. So all these should be equals to 0. So we will be able to solve the X. By this we will be able to solve X. Suppose X comes, I don't know. Suppose X comes 4 volt. Suppose I am saying. So what is they ask this current? So I3 will be voltage difference 4 minus 0, that is 4, divided by resistance, how much? 2. So 2 ampere. Understood? These kind of questions they ask. Clear? So at any junction, if you don't know the voltage, assume it to be X and assume that it is little bit more than the nearing voltage. So current will flow like this, like this, like this, and sum of all the currents to do 0. Next is Kirchhoff's voltage law, KVL. See, these are very easy things. Like for example, what I am saying, suppose we have this is point A, this is 2 volt, this is 4 volt, this is point B, this is 1 ohm, this is 2 ohm. Current flowing is suppose 3 ampere. See how to write. If you are able to understand this now, you will be able to solve a lot of questions. These kind of questions always come in the exam. NEET exam you will see. Always you understand, we will start from any point, whatever you like. and you choose any path. Like suppose we are going from here, you can choose this path also, no problem. You can choose any path, you can choose any point, you can choose any path. But always remember, if you are going from low voltage to high voltage, low to high, we have to add. If we are going from high voltage to low voltage, we have to subtract. I will tell you what add, what subtract. Suppose here the potential is VA. I am writing VA. Correct? Here the potential is VA. Now, when I move from here to this point, from here to this point, tell me, I am going from low voltage to high voltage or high voltage to low voltage? High to low. Why? Because current always flow from high potential to low potential. Current is flowing like this now. So this potential must be high, this potential must be low. So we are going from high to low. If we are going from high to low, we have to subtract. So we will subtract. How much voltage drop will be there across this? V equals to IR. How much voltage drop? V equals to IR. Current is 3, resistance is 1, 3 volt. So I will write minus 3. Okay. Then I am going from high to low. Again high to low. So what will do? Minus. How much? 2 volt. Minus 2. You can see current is in this direction only. Again we are going from high voltage to low voltage. So again what we will do? Subtract. How much? What is the voltage difference here? IR. Current is how much? 3. Resistance is 2. 3 to just 6 volt. 6. Now we are going from low to high. This is low potential, this is high. Low to high plus. So plus how much? 4. Now we reached here. So this potential is equal to this potential. So we write equals to potential at V. So if someone asks what is VA minus VB, VA minus VB, what do you will write? This will go there. 5, 6, 8, 11, 11 minus 4, 7 volt. They ask this kind of questions. This is clear? So if you want to write, you can write in short these things. Now coming back to Kirchhoff's voltage law. See what I told. Suppose I draw a circuit like this. This is 20 volt. This is 2 ohm. This is 3 ohm. What is the current in the circuit? I equals to voltage divided by net resistance. 3 plus 2, 5. That is 4 ampere. So 4 ampere will flow. Correct. 4 ampere will flow here also. 4 ampere will flow here also. Or they are in series. So what will the voltage difference across this resistor? V equals to IR. 4 to the 8 volt. What is the voltage difference across this? V equals to IR. 4 3 ja 12. Now I will make same circuit like this. This is the same circuit. Just clear. This is 20 volt. Here it is 8 volt. Here it is 12 volt. Like this. If I start from any point, you can start from any point. Again, I am saying. Suppose I start from here. And across the loop, you come back to the same point. Okay. What will happen? See. Current is flowing like this, current is flowing like this, current is flowing like this. Suppose this is point A. So I am writing this potential at point A. I am going from high potential to low potential. So subtract minus. How much voltage? 8. Again current is like this. So going from high to low. So subtract. Again I am going like this, like this, like this. From low to high. Add. Plus 20. Now I reached here. So potential at this point, this point, this point, this point same equals to potential at A. So VA cancelled. So 20 minus 12, 8, 8 minus 8, 0. So if you go through the entire circuit, the sum of all voltages will be 0. If you go entire circuit, sum of all the voltage will be 0. Like you choose from here. Suppose you can start from anywhere. I started from here. No? You can start from here. What is the voltage? See. What is the voltage? Like, if I say, because you are going from negative to positive. From negative to positive, it will be plus 20. Now you reached here, negative to positive, plus 20, you reached here. From high to low, you have to subtract minus 8. Again, high to low, you have to subtract minus 12. How much you are getting? 0. Again, you are coming to this point. Huh? So across the circuit, sum of all the voltage, this voltage plus this voltage plus this voltage. If you are going along the loop, it will be 0. So sum of all the voltage across the loop is 0. So this is voltage law. They will not ask voltage law, but these things you should be able to do. Correct. Next, power. Okay. Suppose in the circuit there is one resistor R, current is flowing I, voltage across this is V. Voltage across the resistor is V. Power we defined at 3 formulas. V into I, first formula. V square by R, second formula. And I square R. 3 formulas are there. Okay. Acha. What is power? Means how much energy is flowing in how much time. Energy by time. So sometimes they ask energy. How much energy is flowing through this? How much energy? So energy will be power multiplied by time. Sometimes they ask how much energy it consumes. This resistor, how much energy it consumes. So energy consumes formula power into time. Means energy, power into time. Power is this VI into time. So VIT. Power equals to V square by R into time into T. Power equals to I square R into time into T. So sometimes they ask heat, or sometimes they ask heat energy. Heat energy. Heat dissipated. They will ask in the question, what is the heat dissipated in the wire? Means how much heat is Correct? See, bulb and brightness. Bulb and brightness. What will happen now? Like whatever bulb you buy from market, so any bulb you buy from market, there will be rated power. Rated power means whatever, whenever you go to market and you ask, na, bhaiya, give me 40-watt bulb. So this is rated power. There will be rated voltage also. Rated voltage, suppose 220 volt. What does this mean? It means that if you apply this resistor across, if you apply this bulb across 220 volt, how much power it is going to consume? 40 watt. This is the meaning. If you apply this bulb across 220 volt, how much power it is going to consume? 40 watt. But what you did, you applied this bulb across 100 volt, not 220, 100. Then what is the power consumed, they will ask. Now it won't be 40. Why? Because you have not applied across 220. They have told across 220 it will consume 40. You have applied across 100. What you have to do? First process is find the resistance through this formula. Power rated equals to V square by R. Voltage rated square by R. Like for example, in this example, power rated is 40. Voltage rated is 220. 220 square by R. From here you will get R. Suppose R you get 10. I'm not solving. My intention is to make you understand. Suppose R you get is 10. You will write resistance of this bulb is how much? 10 ohm. Now you can write how much power it is consuming. So power consumed V square by R. What is the voltage across this? 100. Power consumed will be 100 square divided by resistance, that is 10. This is the process. You can do like this is also. What is the current in the circuit? Voltage divided by resistance. 100 divided by resistance, that is 10. How much it is coming? 10 ampere. This is the current. So power we can write like this also. Power equals to I square R. So current is 10. 10 square 100 multiplied by resistance, that is 10,000. How much power consumed? We can solve like this. Always remember, how much power you are consuming is directly proportional to brightness of the bulb. The bulb which is consuming more power, its brightness is more. Correct? Like suppose one question comes, like there is two bulb. like this. $100. Its rated power is 40 watt. This bulb rated power is 60 watt. Which bulb will have more brightness? Don't write 60 is more. So directly this bulb will have more brightness. No. What I told? Power consumed is directly proportional to how much the bulb is consuming power is directly proportional to brightness. This is rated power. Power consumed, I told how to calculate. First you apply resistance. First you find the resistance. Suppose you found that resistance of this is, suppose example I am giving, suppose it is 20 watt, 20 ohm. And suppose the resistance of this bulb is 10 ohm. Suppose. You will calculate the resistance now. How you calculate the resistance? By using this formula. Power rated equals to voltage rated square by R. Voltage rated, if it is not given, take 220 volt. Not this one. Voltage rated, if it is not given, you take 220 volt. So power rated is given, voltage rated is 220, or they will give in the question. So from here resistance will take out. So resistance this, resistance. Now this is 100. What is the current in the circuit? I equals to voltage divided by net resistance, that is 30. So 10 by 3. What is the power consumed by this? I square R. So I is 10 by 3. 10 square means 100 by 9 into R, that is 20. What is the power consumed by this? I square R. I square will be 100 by 9 into resistance, that is 10. You can see this is less, this value is more. So this will consume more power, so this will glow more, its brightness will be more. So this will glow more. One thing I left, I think you must be knowing only, that's why, and that is very important, that's why I am telling you. What is this? Wheatstone bridge. If this is R1, this is R2, this is R3, this is R4, and this is R5. Okay. If R1 by R2 is equals to R3 by R4, then if this condition is happening, then remove R5. No use of R5. No current flows through R5. Now, if they ask what is the equivalent resistance between A and B, it will be very simple. What you do? Because no current is flowing, you remove this. Now, what you can see? These two are in series and these two are in series and they are in parallel. Means it is like this. R1 plus R3. They are in parallel with R2 plus R4. And now you can solve whatever calculation you can do and all. Based on this, meter bridge is based. Last 1 minute I will take. Meter bridge. So meter bridge also same kind of apparatus will be there. Here some R1 is there. Here some R2 is there. Here a wire is there. whose length is 100 meter. A wire is there whose length is 100 meter, and there is a galvanometer. Galvanometer detects current. When there is no deflection or there is current in the galvanometer is zero. Current in the galvanometer is zero, or no deflection. No deflection of galvanometer. They can say anything. Suppose this length is L. So this length will be, always remember this is a 100 centimeter, 1 meter length wire. That's why meter bridge. So this is L. So this length will be 100 minus L. Just you remember this. For zero deflection. For zero deflection, if it is not deflecting, means there is no current, means this by this equals to this by this. So R1 by L equals to R2 divided by 100 minus L. So all, see, almost 90% or 80% we have covered. All things can't be covered in two shots. Okay, you also know. But 80 to 90% I have covered. Go through the lectures, solve questions. It will be quite helpful for you. Okay. We will meet tomorrow. No, not tomorrow, day after tomorrow. Okay. Electrostats.